Hello guys, let us today take few questions on the topic pipes and cisterns and see how we can solve them using various methods. First question is, two pipes A and B can fill a tank in 20 and 30 minutes respectively. If both the pipes are used together, then how long will it take to fill the tank? The first thing to notice is both of them are doing positive work. Both of them are doing positive work. As in, both of them are filling the tank. There is no leak or something like that. So the obvious straightforward shortcut will be multiply these two numbers 20 and 30 and divide by their sum. 20 plus 30 is 50. 600 by 50 is nothing but 12 minutes. So you should right away take this option, 12 minutes. In 12 minutes, both pipe A and B can fill the tank completely. The other method will be always the LCM method. Since the figures involved are 20 and 30, the LCM will be what? 60. So consider the tank to be of 60 liters. Now A can fill this 60 liters in 20 minutes. That means in 1 minute, A can fill in 60 upon 20 or 3 liters. So A can fill in 3 liters and B can fill in 2 liters. 60 upon 30 is 2. 3 plus 2 is 5. So in 1 minute, together they can fill 5 liters of the tank. What is the capacity? Capacity is 60 liters divided by 5, 12 minutes. Again, this is also a quicker method, shorter method, and it really does not involve any calculation on pen and paper. In fact, all these can be calculated mentally, and this is the shortcut which we already discussed. I hope you understand the solutions. Let's take the second question. A cistern can be filled by a tap in 4 hours while it can be emptied by another tap in 9 hours. If both the taps are opened simultaneously, then after how much time will the cistern get filled? As I had explained in the last question that both the taps were doing positive work, here you must notice one is doing positive, another one is doing negative work. So the tap which is filling in the cistern completely takes 4 hours to fill. So it is doing the positive work. Whereas the other one which is emptying out the cistern is doing the negative work. So the question is, can we apply the shortcut of multiplying the two numbers and then dividing it by the sum? Yeah, why not? Let us take the numbers to be 4, and since the second one is doing negative number, we can write minus 9 here, and then sum is what? 4 minus 9. In this case, it will be minus 36 upon minus 5, or you see the negative getting cancelled. 36 upon 5, 5 7 35. So 7.2 hours. Even if we use this shortcut where one of them is doing positive work and the other negative, the answer 7.2 hours is what we can achieve. Now the second method, the LCM method, since the numbers involved are 4 and 9, let us assume the cistern to be of 36 liters. Since this 36 liters is filled in by the first tap in 4 hours, in 1 hour the tap can fill in how much? 36 upon 4, 9 liters. So 9 liters is filled in. Whereas in 1 hour the other emptying tap takes 9 hours entirely, right? So 36 upon 9, 4 hours. Now this 4 liters is being leaked out. If this is positive, this is negative. So 9 liters is being put into the cistern and 4 liters is being taken out. Okay, 4 liters is being taken out. So 9 minus 4, 5 liters is the net amount of water which is present in the cistern. What is the capacity? Capacity is 36. How much time will it take to fill the cistern completely? It is 36 upon 5. Same 7.2 hours is what we had got in this method, and we are getting it here also. So D, option D would be the answer. Let's take the third question. A tap can fill a tank in 6 hours. After half the tank is filled, 3 more similar taps are opened. What is the total time taken to fill the tank completely? As you see in the question that half of the tank is filled. To fill half of the tank, 3 hours is required. To fill definitely the other half, 3 more hours will be required. But now there is not one tap, there are 3 more similar. So in a way you can say that number of taps have become 4 times. If the number of taps have become 4 times, time taken will be 1/4. 1/4 of 3 hours is nothing but 3/4 of an hour is 45 minutes. So not only 3 hours time is required, but we also require 45 minutes to fill the tank completely. I hope you understand the drift. Number of taps have become 4 times, time taken will be 1/4. 1/4 of what? 3 hours, which is same as 45 minutes. So total time taken is 3 hours to fill the half the tank, and then 45 minutes for the 4 taps to fill the other half. Option B. Let's take the next question. A water tank is 2/5 full. Pipe A can fill a tank in 10 minutes and pipe B can empty it in 6 minutes. If both the pipes are open, how long will it take to empty or fill the tank completely? For a minute, you just forget that the tank is 2/5 full. You see that pipe A is working hard and it can fill the tank in 10 minutes. It can fill the entire tank in 10 minutes. While pipe B, which is doing the negative work, can empty in 6 minutes only. So you can see that positive work is less than the negative work. If the tank is entirely full, and you open both the taps, one doing positive work, the other one doing negative work, the tank will actually get emptied out because the negative tap is working faster than the positive ones. Can we apply the shortcut of A into B by A plus B? Yes, let us see. It takes 10 minutes to fill the entire tank by pipe A and 6 minutes to empty the tank completely. So you do the product and the sum, you will see that you are getting -15. What do you mean by -15? This means that in 15 minutes, the tank will get empty. In 15 minutes, the entire tank will get empty. But then you have only 2/5 of the tank full. Not the entire tank. So how much time will it take to empty out that 2/5 content? It is simply 2/5 of 15 minutes, and this is equal to 6 minutes. So in 6 minutes, the tank will get emptied. Hope you understand the drift. What we did is we took the shortcut to find out this -15, which means that in 15 minutes the tank will empty out completely. But we know that the tank was not completely full. The tank was only 2/5 full. So for 2/5 full tank to get emptied out, the time taken will be 2/5 of 15 minutes, which is nothing but 6 minutes. Option A. Let us take the 5th question in the series. pipe A can fill a tank in 5 hours, pipe B in 10 hours and pipe C in 30 hours. If all the pipes are open, in how many hours will the tank be filled? So here we can use the LCM method to find the answer. What are the numbers involved? 5, 10 and 30. And we see that 30 is divisible by both 10 and 5. So you can take the LCM to be 30. Consider the tank to be of 30 liters. Now pipe A, it takes 5 hours to fill. So in 1 hour, pipe A in 1 hour can fill in how much? 30 upon 5, which is 6 liters. Similarly for B, in 1 hour, 30 upon 10. B fills in 3 liters every hour. And C, in 1 hour, only 1 liter. Total in 1 hour, 6 plus 3 plus 1, 10 liters. 10 liters is filled in by all the 3 pipes working together. So to fill in 30 liters, it will take 30 upon 10 or 3 hours to fill the tank completely. There could be a question by students wherein we might be asked whether this method of A into B by A plus B works for 3 pipes or not. In a way we can do. How? Let us first take the first two numbers 5 and 10. What's the product? Product is 50. What is the sum? Sum is 15. So this is same as 10 upon 3. So now we have two figures, 10 upon 3, and what is the third pipe? 30. Can we do the A into B and A plus B here for these two? Yes, we can. 10 upon 3 into 30 by 10 upon 3 plus 30. This is 100. Numerator is 100 and denominator is 100 upon 3. So it is also 3. So in a way, this shortcut A into B divided by A plus B can be applied to 3 pipes also, such that you first take the first two numbers or any two numbers and then get a resultant number, say 10 by 3 here, and then you do the same method A into B by A plus B using these two numbers 10 upon 3 and the third number, which is 30. You will get the value to be 3 hours, and that's option C. I hope you understood both the methods.